Hello, my dear students. How are you? I am Dr. S.K. Das from Regional Institute of Education, Bhubaneswar. Once again, I am standing in front of you for the live interaction about an interesting chapter, motion, of your class, which is in the NCERT textbook. Well, please recall the previous knowledge of the class. In the previous class, we have learnt about the graphical representation of the motion. Then we learnt about distance time graph. We learnt distance time graph in uniform motion, and also we learnt distance time graph in non-uniform motion. We have seen the nature of the distance time graph in uniform motion, and also we have learnt the nature of the distance time graph in non-uniform motion. So then let us see what we will learn today. First of all, we will learn about velocity time graph, both in uniform motion and non-uniform motion. Then we will learn about distance moved by an object from the area under velocity time graph. That is very, very important concept. We have to find out the distance under velocity time graph. Well, let us come to the first learning point, that is velocity time graph. See this picture. What do you see in this picture, students? Well, so this is velocity time graph. Why it is velocity time graph? Because the dependent variable or the dependent physical quantity is the velocity. It is taken along the y-axis. But the independent variable or the independent physical quantity is the time. It is taken along the x-axis. So you see the picture. In the picture it is velocity on the y-axis in kilometer per hour, time along x-axis in hour. So therefore, this is velocity time graph. So before we discuss the velocity time graph, let us go for the analysis of the graph. You must be remembering in the last class I was pressing upon the analysis of the graph, and carefully I was suggesting that you need to analyze the graph. Then only you can get the nature of the motion, then you can understand different parameter of the linear motion from the graph. That's why analysis is very, very important. So if you analyze this graph, what you will see? What would be your analysis? The nature of the graph is a straight line. But you recall the distance time graph, that was also a straight line. But you see this graph, velocity time graph, it is also a straight line. Do you find any difference between two straight lines? Of course, there is difference between these two straight lines. In the previous case, that was a straight line passing through the origin. But here, this is a straight line. Is it passing through the origin? No, not at all. The graph is a straight line, but it is parallel to time axis. Once again you see this picture, this parallel to time axis. Okay, time axis is the x-axis, parallel to x-axis. Then what would be the other analysis, other observation? So object moves with constant velocity of magnitude 40 km per hour, kph. What is kph? Kilometer per hour. So if it is moving with constant velocity, then see at time say 1 hour, what is the velocity? On the y-axis, time 1 hour, see time is mentioned on the x-axis. It is 40 km per hour. Time 2 hour, again see the point is there. So which shows the velocity of 40 km per hour. Then at time 3 hour, again 40 km per hour. Again, at time 4 hour, the velocity of the object is 40 kilometer per hour. So if the velocity of the object is constant, that means the object moves with constant velocity, then the motion here is said to be uniform motion. So here, what is the constant magnitude of the velocity? What is the constant magnitude of that particular velocity? 40 kilometer per hour. So therefore, the object in this case is said to be in uniform motion. So do you understand, students? Well, it's very good. Then what would be your concluding remark? After your observation, first of all you observe the graph, see the graph, then you identify the graph, velocity time graph, then you go for the analysis of the graph, then you need to conclude from the analysis. So what would be your conclusion? In uniform motion of the object, velocity time graph is a straight line parallel to time axis. But in the case of the uniform motion of the distance time graph, the graph was not a straight line. Graph was not, of course it was straight line, but it was not parallel to time axis. But here, in uniform motion of the object, velocity time graph is a straight line and parallel to the time axis. So is it not the concluding remark from your analysis? Well, let us see one more example of the velocity time graph where you need to find out the distance from the area under velocity time graph. Of course, so this is the other learning point. How to find the distance from the area under velocity time graph. Now you see, velocity time graph is a straight line parallel to x-axis or parallel to time axis. Then you take 2 points on this graph, A and B. Do you observe these 2 points on the graph? Yes, A and B are 2 points on the graph. Then from point A and from point B, you draw a perpendicular SC on the time axis, BD, perpendicular BD on the time axis. That means you need to draw true perpendiculars AC and BD on the time axis. So whenever you draw two perpendiculars on the time axis, you find a quadrilateral. A, B, D, C is the quadrilateral. Here C, A, B, C, D, it is mentioned on the velocity time graph. So here A, B, C, D is a quadrilateral. Now the area of the quadrilateral, this ABCD quadrilateral is equal to length into breadth. You know the length say CD is the length and AC is the breadth. So area of the quadrilateral ABCD is equal to length into breadth is equal to CD into AC. Now you see, what is CD? CD is the time difference between T2 and T1 time. So if it is a time difference between T2 and T1, then CD is equal to T2 minus T1. Then what is AB? Sorry, what is AC? AC is the breadth of this quadrilateral. So that is the uniform velocity, V. So here uniform velocity is 40 kilometer per hour. So AC is V, that is the uniform velocity, and CD is T2 minus T1 is equal to T. Therefore you see, this analysis of the area of the quadrilateral ABCD is equal to length into breadth is equal to CD into AC is equal to T2 minus T1 into V is equal to T into V. So I have already mentioned T2 minus T1 is equal to T and AC is equal to V. But we know from the definition of the velocity, it is the displacement per unit time, or magnitude of velocity V is equal to distance by time. So distance S is equal to V into T. Now area under velocity time graph. If you see, area under velocity time graph is also equal to velocity into time, Vt, is equal to length into breadth is equal to Cd into AC. So therefore area under velocity time graph is the area of the quadrilateral ABCD is the distance covered by the object, because S is equal to V into T is equal to length into breadth of the quadrilateral ABCD. Therefore, area under velocity time graph is the area under the quadrilateral ABCD is the distance covered by the object. S is equal to CD cross AC is equal to Vt. Once again it is mentioned. Do you understand, students, how to find out the distance from the area under velocity time graph? Is it not interesting? Yes, certainly. The parameter like distance you can find out from the area under velocity time graph. Well, so what would be your concluding remark after going for finding the area, finding the distance covered by the object? Area enclosed by velocity time graph of an object is in uniform motion in a given time, gives the measurement of the magnitude of the displacement or distance. I have already explained in my analysis. S is equal to Vt, that is the area under velocity time graph. So area enclosed by velocity time graph of an object in uniform motion in a given time gives the measurement of the magnitude of the displacement or distance. Is it not the concluding remark from such findings? Well, students, so you understood this particular concept very well. So thank you for your analysis, and thank you for your interest in finding the distance from velocity time graph. Well, let us take an example which shows the velocity of a car at regular instant of time in linear motion with the help of a table. Do you see the table? Well, so how many columns are there in this table? Two columns are there. One is the time column and the second is the velocity of the car column. Time is mentioned in second and velocity of the car is mentioned in 2 units. First unit, meter per second. The second unit, kilometer per hour. Kilometer, h to the power minus 1, kilometer per hour. If you look the table carefully, at time 0 second, the velocity of the car is 0, both in meter per second and in kilometer per hour. That means the car is in the state of rest initially at time t is equal to 0 second. Then if the car starts moving, then at time t is equal to 5 second, the velocity of the car is 9 meter per second or say 2.5 kilometer per hour. Students, here you see, if you convert 9 meter per second into kilometer per hour, it is 2.5 kilometer per hour. Please check it, students. Don't take it granted that 9 meter per second must be 2.5 kilometer per hour. You go for some calculation, then see 9 meter per second is equal to 2.5 kilometer per hour. Then at time 10 second, the velocity of the car becomes 18 meter per second or 5 kilometer per hour. Then at time 15 second, the velocity of the car is 27 meter per second or 7.5 kilometer per hour. Then at time 20 second, then the velocity of the car is 36 meter per second or 10 kilometer per hour. At time 25 second, the velocity of the car is 45 meter per second or 12.5 kilometer per hour. Or when the time is 30 second, the velocity of the car becomes 54 meter per second or 15 kilometer per hour. So after observing this table, you need to go for plotting the velocity time graph. So that is the best, exercise you need to do here. We have to go for graphical analysis of velocity time graph. Here we have the time t and we have the velocity v. So we can plot the graph with the help of the graph sheet. So take a graph sheet and take x-axis. In the x-axis you take time because that is the independent physical quantity. Along the y-axis take velocity, that is the dependent physical quantity. Now check the units, check the scale, that is very important. At the origin O, so both the coordinates x coordinate and y coordinate must be 0, 0. So whenever you go along the x-axis, then time becomes 5 seconds, 10 seconds, then 15 seconds, 20 seconds, like that. Then if you go along y-axis, velocity is 10, this is meter per second, then 20 meter per second, 30 meter per second, and so on. So you need to go for plotting the graph by taking the x coordinate and y coordinate simultaneously from the table itself. Then you see there is equal increase in velocity. Is velocity increasing? Yes. Initially it was 0, then 9 meter per second, then 18 meter per second, then 27, then 36, then 45, then 54 meter per second. Is not the velocity increasing? Certainly, the velocity is increasing. But how the velocity increases? The velocity increases with equal increase in velocity with equal intervals of time. Remember, equal increase in velocity with equal interval of time. So how do you see in the graph? From the straight line, nature of the graph passing through the origin. If the graph is a straight line passing through the origin, then there is equal increase in velocity with equal intervals of time. You recall the previous class. In the previous class, the distance time graph was a straight line passing through origin. So that means there is equal increase in distance with equal interval time, equal change in distance with equal interval time. The motion was uniform in the distance time graph. So same thing, it is happening in velocity time graph. Velocity increases and increase in velocity is equal with equal intervals of time. Okay. So we need to analyze the graph. I have already explained, whenever plot any graph, we need to go for analysis. If you go for analysis of the graph, what do you see? See, the nature of the graph is a linear one, that means straight line, passing through the origin. Then you see there is equal change in velocity or increase in velocity. Here the velocity increasing. Equal increase in velocity or change in velocity of 9.8 meter per second. So how do you see? You see from this graph, 0 to 9 meter per second, 9 to 18 meter per second, 18 to 27 meter per second. So the change in velocity or the increase in velocity of 9.8 meter per second with equal interval time of 5 seconds. See, 5 seconds because 0 second, 5 second, 10 second. So interval is 5 seconds. So therefore, there is equal change in velocity or equal increase in velocity of 9.8 meter per second with equal intervals of time, that is 5 second time. Now see the slope. I have already explained about slope while you discussing in distance time graph. Here slope you can find out from the right angle triangle, that is AED right angle triangle. So here you see the slope of the graph is constant in this velocity time graph. So if the slope of the graph is constant, and I have already explained that whenever the slope of the graph is constant, then obviously the car moves in uniform motion, of course. But here it is uniform acceleration or constant acceleration, because the definition of acceleration says that it is the rate of change of velocity per unit time. So that's why here rate of change of velocity per unit time is constant, which is obtained from the slope of the graph, which is constant. Therefore, this is the case in which the acceleration of the object or the acceleration of the car is constant. So therefore, the slope tan theta of the graph is constant due to which car moves in uniform or constant oscillation. Then let us discuss how to find distance from velocity time graph under uniform oscillated motion. Students, you please recall that we have already discussed how to find out distance from velocity time graph whenever the oscillation was 0. Do you remember that? Because whenever the oscillation is 0, the velocity time graph must be a straight line, but it must be parallel to the time axis. We have already discussed. And we have taken the rectangle and we have found out the rectangle, area of the rectangle, and we determine the distance traveled by the object from velocity time graph. But here the motion is uniform oscillated motion, because the velocity time graph is a straight line passing through the origin and slope gives the acceleration. Therefore, the slope is constant in this case and the acceleration is constant. So it is uniform oscillated motion. So then take 2 points on the graph. One point is A and the other point is E. Then draw perpendiculars. That is A, B is the perpendicular from A on the time axis. Then you draw another perpendicular EC from the graph on the time axis. 2 perpendiculars AB and EC you have dropped on the time axis. And you find a quadrilateral. What is that quadrilateral? Can you tell me the name of that quadrilateral? Of course, A, B, C, E is the quadrilateral. Whenever draw perpendicular, then the quadrilateral is ABCE. Then the distance covered by the object can be calculated by means of this velocity time graph. Okay, so from the area, so S is equal to distance is equal to velocity to time is equal to distance traveled is equal to area under velocity time graph. That is area of the quadrilateral ABCE is equal to area of the rectangle ABCD, because you see in the quadrilateral one rectangle is there, that rectangle is ABCD, and one triangle is there, ADE triangle is there. So therefore, area of the quadrilateral ABCE is equal to area of the rectangle ABCD plus area of the triangle ADE. But you know how you can find the area of the rectangle? Length into breadth. So length is equal to AB, breadth is equal to say BC. So area of the rectangle is AB cross BC or AB into BC plus area of the triangle. What is the formula for area of triangle? From mathematics you must be knowing. Area of the triangle is equal to half base into height. So therefore it is 1 by 2 into base of the triangle AED is AD, half into AD into height is equal to D. Therefore, the area of the rectangle ABCD plus area of the triangle ADE is equal to AB into BC plus 1 by 2 into AD into D is equal to distance traveled by the object, okay, is equal to area under the velocity time graph. So by means of this calculation, you can find distance covered by the body or the object from velocity time graph. Do you understand, students? Well, so then let us discuss these particular concepts with the help of some interactive questions. Unless you discuss the concept with the help of the interactive questions, you cannot understand well. See the first question. The first question is, what is the distance traveled by the object in the following graph? I have given this graph. Can you identify the graph, students? Yes, it is velocity time graph. From this velocity time graph, you have to find out the distance. Well, so how do you find? Can you solve this particular question? Well, let us see the solution. In this case, velocity of the object is equal to 40 km per hour. Of course, it is the magnitude of the velocity, or you can say speed of the object is 40 km per hour. The time t is equal to t2 minus t1, that is equal to 2.7 hours. Then distance covered by the object is equal to area under Vt graph, velocity time graph, is equal to length into breadth, is equal to V into T, we have already discussed, is equal to 40 km per hour, because V is equal to 40 km per hour, and T is equal to 2.7 hour. Carefully you see this, T is how much? 2.7 hour. Whenever you multiply, this is 108 km. So this is the distance covered by the object. Let us see the second question. Find the acceleration of the object in the following graph. Velocity is there, time is there, and you see the units, see the scale, then you have to find out the acceleration. How to find the acceleration? From the slope. If you find the slope of the graph, then you can find out the acceleration. So the acceleration of the object is the slope tan theta of the graph. A is equal to tan theta is equal to perpendicular divided by base, dE divided by AD. See, dE is the perpendicular, base is AD, but dE is equal to CE minus CD divided by AD. What is C? C is the 36 meter per second. CE 36 meter per second. CD is 18 meter per second. So CE minus CD is equal to 36 minus 18 meter per second divided by AD. So AD is the time. So this time is 10 seconds. So whenever you solve, it is equal to 18 by 10 meter per second square equal to 1.8 meter per second square. So meter per second square is the SI unit of acceleration. Let us see the third question. Find the distance covered by an object in the following graph for t is equal to 10 seconds. Here t is equal, time is equal to 10 seconds. Again it is velocity time graph. So you have to find out the distance. So solution is like this. S is equal to distance covered by the object is equal to area of the quadrilateral ABCE, I have already explained, is equal to area of the rectangle ABCD plus area of the triangle AD, I have already explained, is equal to AB cross BC, I have already explained, plus 1 by 2 AD cross DE, I have already explained. So that is the area of the triangle. You substitute the value of AB, that is 18 meter per second, into substitute the value of BC, 10 seconds. That you need to do very carefully. Plus 1 by 2, substitute the value of AD, 10 seconds, because this is the time, into substitute the value of DE, that is 18 meter per second. Then it will be equal to 180 meter plus 90 meter is equal to 270 meter. So distance covered by the object is equal to 270 meter. Let us see one more question. Question number 4. Interpret the following graph. I am giving you the task to interpret the graph and find the acceleration of the object. So what is the name of this graph? It is velocity time graph. Then go for its interpretation. So velocity increases or decreases? The graph is, moving downward. That means velocity decreases. But it is a straight line. Velocity decreases uniformly with time. That is equal decrease of velocity with equal interval of time. See the graph once again. Equal decrease of velocity with equal interval time. Acceleration is negative. We have already explained this concept of negative acceleration in our previous class. If final velocity less than initial velocity, then the acceleration is negative. So here the acceleration should be negative. Then it is uniform accelerated motion. Of course, the acceleration is constant, negative acceleration. It is retardation. Then the acceleration of the object, if you calculate, A equal to tan theta is equal to slope of the graph. I have not mentioned the angle theta. You please see that and go for its calculation. A equal to tan theta, I have already solved this question, but you see whether this answer is correct or not. That is tan theta is equal to perpendicular divided by base. So 20 meter per second divided by base is equal to 6 seconds. Whenever you solve, then it will be equal to 3.3 meter per second square. Well, let us see one more question. Beautiful graph, beautiful picture is there. Then you have to interpret this graph and find out the oscillation in 4 phases. Why 4 phases? Because in the first phase, the graph is increasing. Second phase, again the graph is down, decreasing. Then again, after some time, the graph is increasing. Then after some time, the graph is decreasing. That means there are 4 phases of the motion of the object that is depicted in the graph. Then can you solve this question? First of all, interpretation. The motion is non-uniform because it is increasing velocity, decreasing, then decreasing. Then the motion is non-uniform due to non-uniform rate of change of velocity. Rate of change of velocity is different. That's why motion is non-uniform. It's a very good analysis from this graph. So in the first phase and third phase, velocity increases. See, first phase, third phase, the graph is increasing. That's why velocity increases and acceleration is positive. But in the second and fourth phase, second phase and the fourth phase, the graph is moving downward. That's why the velocity decreases and the acceleration is negative. So if you find the acceleration, I have not calculated, I have shown the answer directly. Acceleration in the first phase, if you calculate, then it is 3.75 meter per second square. Acceleration in the second phase, 3.0 meter per second square. Acceleration in the third phase, 2.5 meter per second square. Acceleration in the fourth phase, 1.875 meter per second square. That means object moves with different acceleration, non-uniform acceleration. Acceleration gradually decreases. Well, students, I am giving you an activity. Are you ready for doing the activity? Well, see the activity with the graph sheet. I have mentioned, take a graph sheet and draw the velocity time graph of an electric train by using the given table and find the acceleration and distance traveled during the acceleration. Whenever it is accelerating, you have to find out the distance traveled by the electric train. Then again you have to find out the retardation and distance traveled during retardation. Then you have to find out the average velocity. So see the table. Time in the first row, velocity in the second row. Time is in minute, velocity is in meter per second. At time 0 minutes, velocity is 20 meter per second. At time 1 minute, velocity is 28 meter per second. Then at time 2 minutes, the velocity is 36 meter per second. Time 3 minutes, velocity is 44 meter per second. Time 4 minutes, velocity is 22 meter per second. At time 5 minutes, velocity again 0. Now you have to, plot the graph. First of all, plot the graph, okay. Then you have to, find out the acceleration, okay. Then find out the distance traveled. I have given its answer in the bracket. Acceleration would be 0.133 meter per second square. And distance traveled during that acceleration, 5.76 kilometer. And in the next case, you find out the retardation, negative acceleration. That is 0.37 meter per second square. Distance traveled 2.64 kilometer. And average velocity of the train, 28 meter per second. Carefully, you go for calculation and see, check whether this result is correct or not. So by doing this activity, so you can plot a graph and you go for analysis, go for calculating the acceleration, distance traveled, retardation, then distance traveled. Are you enjoying the graph? No? Are you enjoying the activity? No? Well, very good. Then let us see what we have learned today. So first of all, we have learnt about velocity time graph. If the velocity time graph is parallel to time axis, then the motion of the object is said to be uniform with zero acceleration. Remember, velocity time graph parallel to the time axis, then the acceleration must be 0. Then if the velocity time graph is a straight line having constant slope at different instant of time, then the motion is said to be uniform accelerated motion. Previously it was uniform velocity, therefore acceleration is equal to 0, but now it is non-uniform velocity, therefore the object moves with uniform accelerated motion. Then we have learnt about area enclosed by velocity time graph. Area enclosed by velocity time graph gives the distance traveled by the object in given time in linear motion. This is a very important concept we have learnt today. Well, students, so today we have learnt velocity time graph in uniform motion, that is uniform velocity and non-uniform motion, that is non-uniform velocity, and we have understood how to calculate the distance traveled by the object from the area under velocity time graph. So you must have enjoyed the topic. Thank you, students. So next class we'll discuss about the equation of motion and how to derive the equation of motion. Then we'll discuss about the circular motion. So these are the two things left in this chapter. So next class we'll discuss all these things. So now I would like to thank you all because of your patience hearing and for your interest on the subject, and hope you will be doing something very significant so in your in your career in future. Thank you.